This is going to be a video lesson on graphing equivalent ratios, which you should watch on January 12th. On your guided notes, if you're in person, you should receive the guided notes with a lot of blinks, and we're going to fill in all those blinks together. Starting with the first part of the first problem. Every 4-ounce serving of Yum's yogurt contains 8 grams of protein. Complete the table of equivalent ratios. So if you can recall before winter break, this is before winter break material. Using the information it gives you, you have to complete the table. But notice that there's no completed rows. That's because you have to take that information they give you up here and use it to fill in one of the rows. If you haven't already done so, I suggest you pause the video. You do have to write this problem down. There's some space there for you to write this information down, and then fill in the table as such. So yogurt on the left, protein on the right, and then on the left 4, 8, 12, and then on the right 32. So it says for every 4-ounce serving of Yum's yogurt, it contains 8 grams of protein. So I'm going to find the 4 ounces of yogurt right here. So 4 ounces of yogurt, there's 8, 8 grams of protein. So now, since this is a table of equivalent ratios, if you can remember, our job is to find the relationship and apply the relationship. So in this case, how do you go from 4 to 8? Well, right off the bat, I know that 4 times 2 is 8. So then I go to the other side and I do the exact same thing. 8 times 2 would be 16. So if I drink double the yogurt, I'm going to get double the protein. Makes sense. I'm going to keep going down. So next row, how do I go from 4 to 12? Well, I know that 4 times 3 is 12. I'm going to go to this side, do the exact same thing. 8 times 3 would be 24. And then the last one, now I have to look on this side because this side is the side that has the number I can use to develop a pattern. How do you go from 8 to 32? That is times 4. So I go over here and do the exact same thing. What's 4 times 4? Hopefully whispered 16. Again, this is something we did before winter break. And I do want to point out that this table is in order. So it's like the first multiple, then times 2, then times 3, times 4. I just picked an easy one to start with. Usually it won't be in order. It'll purposely be out of order just to kind of actually make you think about the math. So this pattern where it's times 2, times 3, times 4 doesn't always necessarily exist. In some cases, it will pop up. but in most cases it will not. You guys saw a lot of examples of that before winter break. Alright, so since this is old stuff, how are we going to take this and apply it differently? So that's where I'm going to go on to next page. So the second part of this problem is after we completed the table of equivalent ratios, it says plot points on the graph to represent the ratios. So let me fill in the blanks here. This was an 8. This was 16. This was 24. And this was 16. So each of these is a point when it's together. This is a graph, which you saw yesterday on Khan Academy. This is what we call a graph or a coordinate plane. The bottom axis, this one, the one that goes across, is your x-axis. So in this case, x is yogurt. That's very important to note. I'm actually going to go over here and put this side is my x. The vertical axis is the y. And y is going to be protein. So I'm going to go over here and put y. Usually it will always be in order. X will always be on the left, y will always be on the right. But it's very important that you just take those 5 seconds and make a note of that. Like, hey, this is my x side, this is my y side. So I'm going to take it one step further. I'm going to write these as points. So this point is going to be 4, 8. And then I'm going to have 8, 16. 12, 24, and then the last point is going to be 16, 32. So in my graph, I should plot these points. Actually, I want you to do something for me. If you can pause the video and graph these points on your own using a pencil, that would be great. And then hit play once you're done. That way you can just confirm that you got the points in the right spot. By doing so, you just take initiative and apply your own learning from yesterday before I give you the answers. It doesn't benefit you if you just copy the answers. But if you apply what you learned, that's more beneficial to your education. Go ahead and pause the video now and then hit play once you're ready. Hopefully you paused the video and now you're ready to see if your points match up with mine. So let's get started. So 4, 8. Remember, this is x, this is y. So for 4 ounces of yogurt, this actually might be a problem that some of you ran into yesterday. There's no 4 down here. I need 4 ounces of yogurt, but there's no 4. So we have to take initiative and kind of make a guess as to where 4 is going to be. So if you notice, every 2 lines is 8. So that means every line is probably going to be 4. So 4 would be right in between. This would be 12, etc. And you can kind of get the gist of it. So 4, 8. So always starting at the origin, you go to the right. In this case, 4. Notice that I'm not hopping 4 times and going to 16. I'm just going to the 4. So going to 4 and then up to 8. So that's my first point. Check. Second point, 8, 16. So starting at the origin, I'm going to go to the right to 8 and then I'm going to go up to 16. Check. Third point, starting at the origin, I'm going to go to the right, 12, and then I'm going to go up to 24. And then the last point, 16, comma 32. So starting at the origin, I'm going to go to the right, 16, and then up to 32. And check and check. So those are the 4 points that we had to plot. Now, some of you might notice that I have a way of plotting my points. Maybe you do it differently, like you just know where the point is at. I'm just trying to build a pattern. So that's always my pattern. Always start at the origin. You go to the right first, and then you go up. Start at the origin, go to the right, then up. Start at the origin, go to the right, then up. Because again, I've told you guys this before, math is all about patterns. Find a pattern and then use the pattern. And that's going to be the pattern here. The first number tells you how many spots to go to the right. The Y tells you how many spots to go up. And hopefully this problem wasn't too hard for you. This is the gist of everything we're going to do with equivalent ratios. We'll complete some tables, and then we'll graph those tables. Let's move on to slide 3. And for you, that should be problem 2, still on the front side of the guided notes. Number 2, Jordan and Mia are bringing napkins to a back-to-school picnic. They decide to bring 35 napkins for every 10 people who plan to attend. The point on the graph represents this ratio. So they already put a point here. So 35 napkins, 10 people. I'm actually going to put the 35 in just for clarity. So the point that's already in the graph just tells us this information. Part A, plot another point that represents an equivalent ratio. Explain how you found the coordinates of this point. So I'm going to take a short pause here, just a few seconds. Go ahead and pause the video. My in-person students, you have guided notes. You should have already paused the video, but if not, can you pause the video and copy the word problem and part A down? All right, hopefully you were done writing the information down after pausing the video. We were just getting started on part A. Part A, plot another point that represents an equivalent ratio. Explain how you found the coordinates of this point. So when it says plot another point, some of you may think like, oh, I'm just going to go over here and put a point. I don't know, that. See how that works. But that's not essentially what it's asking. Remember, this is equivalent ratio, so we want to keep it equivalent. So I'm going to use the ratio they give me. So 35 napkins. Ten people. Using this ratio, I just want to make an equivalent ratio. So let's say, I don't know, let's say there's not 10 people, there's going to be 20 people. So I'm going to multiply this by 2. So now there's 20 people. Well, if there's 20 people, how many napkins are Jordan and Mia going to bring? So let's multiply the top by 2. 35 times 2 would be 70. So Jordan and Mia are going to bring 70 napkins for 20 people. I'm going to write that as a point. People is x-axis, so this is x. So 20, and then y is going to be the number of napkins. The y-axis is right here, that's napkins. Now that I have the point, I'm going to go here. So 20, start at the origin, go to the 20 on the x-axis, and then go up to 70. That is how you plot another point that represents the equivalent ratio. You could have also did times 3. If you took the first ratio and multiplied it by 3, you would have 30. So go over to 30 and then up to 105, which would be here. And let's answer part B now. What coordinates, or no, sorry, misspoke. What do the coordinates of the point you plotted represent in this situation? So these are the coordinates, 20, 70. The x coordinate, 20, means that they need 20 people. The y coordinate of 70 means that they need 70 napkins. And that's what the coordinates mean. Maybe I'll rephrase the top one. I guess you don't need a specific number of people. The x coordinate of 20 means that there might be 20 people that they need 70 napkins for 20 people. The x coordinate of 20 means that there might be 20 people. The y coordinate of 70 means that they need 70 napkins for 20 people. So if 20 people show up, they're going to need 70 napkins to keep their equivalent ratio the same. This was number 2 of the guided notes. We're going to move on to the next problem. Number 3. Alan is making a scarf for charity. He uses 4 yards of black yarn for every 6 yards of yellow yarn. Complete the table of equivalent ratios and plot the points. This is going to be exactly like number 1. So what I want you to do, as I always recommend, you guys are independent learners, pause the video, take, I don't know, 3, 4, 5 minutes, however long it takes you, complete this problem in its entirety, so all the way through, then play the video just to check your answers. The reason I recommend this all the time is because you guys are so smart and you guys can apply what you learned before I even give you answers. Go ahead and pause the video now, complete the problem. All right, hopefully you pause the video and now you're ready to get some answers to compare. So it says Alan is making a scarf for charity. He uses 4 yards of black yarn for every 6 yards of yellow yarn. That information is already right here. So let's fill in the blanks. How do you go from 4 to 2? Well, that would be, I can take 4 and cut it in half, which means divide by 2. So I go over here, do the exact same thing. 6 divided by 2 would be 3. Now, usually we always use the starting ratio, but this time I'm gonna use the base ratio just to prove to you guys that there's some different ways you can solve this. So I know 4 times 3 gets me 12, but why don't I do 2 times 6 equals 12? Do the same thing down here. That is 18. And then, like I said, another option would be 4 times 3 is 12. So you would do 6 times 3, which is still 18. Both methods work. Last column, how do you go from 3 to 30? That one's an easy one. 30 is 10 times 3. Go to the top. So what's 2 times 10? 2 times 10 would be 20. So I've completed the table of equivalent ratios. Now B, plot the ordered pairs on the graph. So these tables are the ones you got to pay very close attention to, because I told you that if a table is like this, X will always be on the left, Y will always be on the right. But these are vertical tables, so it's kind of easy to see. These horizontal tables, you actually have to make a note of which one is X, which one is Y. It can change on these. So go to over here, X axis. Everything starts with X. So X, this is X axis. That is going to be the black yarn. So the top is going to be my X coordinate. That means the Y axis is the yellow yarn. So I'm going to write these points out. So starting with the first column, this is X. So X goes first, 2, 3. Next, X is 4, Y is 6. Next, 12 is X, 18 is Y. And then last, 20 is X, Y is 30. I noticed that this table does not go in order. It's not times 2, times 3, times 4. So this is a good example. This is how most of the tables are going to be, where it's going to be like a random order. I did want to just take a second to point that out. All right, now I'm going to plot these points. So starting at the origin, go to 2, on the right, but 2 is missing. But I know that halfway between 0 and 4 would be 2, and then up to 3. That might be hard to see for you guys, so I'm going to change color. Next point, 4, 6. Go to 4, and go up to 6. Next point, start at the origin, go to the right until you hit 12, then go up to 18. Last point, start at the origin, go to the right to 20, go up to 30. Those are the 4 points that they wanted me to graph. Hopefully, like I said, you paused the video before we did this together, and hopefully this confirmed that you can do this without my assistance. Alright, we have one more. Number 4. An aquarium that holds 9 gallons is the correct size for 3 miniature goldfish. The point on the graph represents this ratio relationship. Which ordered pairs represent equivalent ratios that would also be on the graph? Select all that apply. So basically all we have to check to see is which ratios, which points, if I read them as ratios, are equivalent to this one. So I'm actually going to type this out. Maybe that'll look a little bit better. 9. Well, let's start by picking where X and Y are going to be. So X-axis, that's gallons. Y-axis is goldfish. So 9 gallons, 3 goldfish, 1. First point, 1 to 3. Well, this one's pretty easy. To go from 9 to 1, that's divided by 9. But does 3 divided by 9 get you 3? Hopefully you answered no. This is not correct. So A is not good. Then we go to the next one, B. 9, 3, 3, 1. So how do you go from 9 to 3? That's divide by 3. Go to the right side, do the same thing. Does 3 divided by 3 equal 1? Yes. So B is an answer. Since this was my starting ratio, and I divided it, this is the smallest it can get, so this is going to be my base ratio. This is the easiest ratio of the set. So for the rest of them, I'm going to use this one to check instead of using 9 to 3. So 3, 1, 12, 6. How do you go from 3 to 12? Times 4. Do the same thing to the other side. Does 1 times 4 get you 6? No, it does not. 1 times 4 is 4, not 6. Then we have D. And let me just show you why I picked the base ratio with this one. So let's say I did use 9 to 3 for every one of them. Let's say you tried like asking yourself, how do you go from 9 to 15? That's really not that easy because that would be a decimal. You can go from 9 to 15. So for that reason, that's why once you have the base ratio, it's super uh super easy to use that one rather than the ratio they gave you. All right, 3 comma 1, and then I'm comparing it as an equivalent to 59. How do you go from 3 to 15? Times 5. 1 times 5, does that equal 9? That would be a big no. And last one. 3 comma 1 again. I'm comparing it with 18, 6. 3 times 6 is 18. And then I do the same thing over here. 1 times 6. This one does equal 6, so this is my second answer. I'm going to go ahead and plot these points on the graph just to get some more practice. So starting at the origin, go over to 3, then go up to 1. Starting at E, or I'm starting with E, starting at the origin, going over to 18, then I'm going up to 6. And that is the final problem. I do want to make a note of something that just might be very beneficial for you. So if you notice all the graphs, every graph, if you look at the points, and we know that graphs are usually lines. So let's say I connected all the points. You don't have to do this. I'm just using this for talking purposes. Now, if I wasn't doing this on a computer and I was doing it on paper with a ruler, what would you notice about all these lines? One thing I notice is that all these lines are perfectly straight. So because equivalent ratios have a pattern that they're all the same ratios, they're just multiples of one another. When you graph them, it makes this cool thing where all of them are going to be straight lines. So technically, for this last problem, I could have done it differently. Instead of doing all this work, I could have just drew a straight line and then checked which of these are on that line. 1 to 3, 1 comma 3. Let's see, where would that be at? 1, 3 would be like right here. That's so far from the line, so that A wouldn't work. C, 12, 6. 12, then up to 6 would be right here. That is not on the line, so C does not work. And then D, 59 would have been right here. Is that on the line? Nope. So that's not an equivalent ratio. Just another option moving forward. We're going to speak on that a little bit tomorrow and the importance of that straight line. All right, make sure you wrap up anything you need to wrap up. If you need to go back and rewatch a specific portion of the video, go ahead and do so. Thank you guys. You guys were awesome. If you still have time, I'm going to post a spiral review video on some of those problems. That way you can knock a portion of that out. Thank you guys.